So today I'm going to show you guys how to draw the unit circle. I'm also going to explain what the unit circle is used for and why we have it, specifically when we do trigonometry. I'm also going to show you guys easy ways to remember the unit circle without having to look it up on your phone or use a reference to create it, because there's many patterns within it that if you can remember those simple patterns, you'll be able to very easily recreate or draw the unit circle in a matter of minutes. So to start the unit circle, the first step you're going to want to do is to shockingly draw a circle. I'm going to pause the video and do that right now. So it doesn't have to be a perfect circle. As you can see, mine's not that perfect. It's just a circle. It'll do. The first thing you need to do for your unit circle to get it started and get the basic shape of the unit circle down is draw an x-axis and a y-axis. So I'm going to do that real quickly and show you what it looks like. Not very hard. I got my x-axis done and my y-axis done. Now that we have the basic shape of the unit circle, we can get started to, I'm going to get started showing you guys how to draw the unit circle. So at each of the points where the axis meets the circle, there's going to be an angle, a radian, and a coordinate. Now they all have one, except here, the start one, which will have two angles in degrees and two radians, but only one coordinate because it's still the same spot. So, unlike a regular circle, it's like a circle because it increases in 90-degree increments when you go around 1/4 of the circle. It's not like a regular circle where you'd usually read a circle going from the top and going clockwise around it. For the unit circle, you start here and go counterclockwise. So I'm going to show you guys the degrees. I'm just going to pause the video and do that real quickly so you guys can see it. It's very simple, so I'll be back in a sec. So like I said, nothing too complicated to do from the start. You start here, you have 0 degrees, which is 0 pi over 2, which is 0. You go up to here, 90 degrees, pi over 2. I'll explain to why these ones are the way they are, why they're all the way they are later when you remember it, so I'll get to that later. Over here, you have 180 degrees. Simple enough. That's actually 2 pi over 2, which you simplify to pi. And then 270 degrees. That's 3/4 of a circle. And you finish off with 360 degrees. That's actually 4 pi over 2, but if you simplify that down to 2 pi. So that's why I have that as 2 pi. The coordinates are very simple to understand. This is x-axis, and the y-axis, they go to 1 and -1. So that's at 1, 0, because it goes along the x-axis and doesn't go up or down. That's 0, 1, it goes up and down the y-axis, but doesn't move left or right. That's the same thing, it's just backwards, and that's the same thing, it's just backwards of that. It's simple to understand. There, we got that, that's simple. I'm going to fill in all the blanks that we're going to have to fill in, and I'm going to go step by step and show you guys what to do to fill it in now. So, I'll get back to you guys in a second when I'm done that. For me, the first and easiest thing I'm going to show you guys is to what the degrees, how to increase the degrees as you go around the unit circle. Now, there's a very simple pattern to follow in each quarter of the circle. If you start from here, going up to there, if you start from, let me rephrase that, if you start from an axis, going counterclockwise to the next axis, it'll always increase, starting from here, it'll go 30, up by 30, then by 15, then 15 again, and then 30. So we're going to fill that in real quickly following that rule, the 30, 15, 15, 30 rule. That's what I call it, just to remember it. It's not called that. I don't know if there's a name for it. That's what I call it to remember it. So I'm going to do that real quickly and show you guys. Now, we'll count real quickly. 0 plus 30 equals 30. 30 plus 15 equals 45. 45 plus 15 equals 60. 60 plus 30 equals 90. Now, all you have to do is just keep doing the 30, 15, 15, 30 rule and keep going and doing that around the entire unit circle till you fill it in. Now, I'm not going to waste time counting every single one. If you want to, you can just pause the video wherever you like and check and make sure, but trust me, it does follow that rule. So what we're going to do next is get into the radians going around the unit circle. And the first thing I'm going to show you about the radians is a pattern for what it's over, what the denominator of the radian is. Starting off, the one that's always closest to the x-axis is always over 6. So we're going to fill that in real quickly, and I'll show you what it looks like. That's pretty simple. Just the one closest to the x-axis is always over 6. Pretty simple to understand, pretty simple stuff. The one that's always closest to the y-axis is always over 3. I'm going to fill that in, show you guys what it looks like. Again, very simple. So, as you can see, over 3, over 3, over 3, over 3. Now the one in the middle, you're probably guessing it's either going to be 4 or 5, because it's in between 3 and 6. It's 4, so the one in the middle for every quarter of the unit circle is always over 4. Pretty simple. So 3, always closest to the y-axis. 6, always closest to the x-axis. 4, always in the middle. Now, I'm going to show you guys, because it's always something pi over it. I'm going to put pi over all of these, and then I'll show you the patterns of what you're supposed to put over it. So, let me do that real quickly. So now that I have all the pi's filled in, I'm going to show you the pattern for the first one, which is basically the easiest one there is. It's always just pi. So you have pi over 6, pi over 4, pi over 3, and pi over 2. Now the next one starts to get a little tricky. Still fairly simple though. I'm going to fill that in and explain to you what the pattern is. I'll get back to you guys in a second. Now it's starting to get a little bit trickier as you have different numbers that are being involved. My camera's out of focus. Let me get that fixed really quickly. There we go. It's not just pi again. It's not just as simple as putting pi over it. The pattern here is that the numerator is always going to be 1 less than the denominator. And we'll start up here. 1 pi over 2. 1 is 1 less than 2. 2 pi over 3. 2 is 1 less than 3. 3 pi over 4. 3 is 1 less than 4. 5 pi over 6. 5 is 1 less than 6. It may look complicated, but once you learn the patterns, like I said, it's actually very simple to learn. Now we're going to go on and do the third part of the unit circle, and I'm going to explain that one. So I'll be back in a second. Now, again, more complicated numbers that look like it's difficult to understand. It's actually fairly simple. For these 4, the pattern is actually the exact opposite of these 4. Instead of 1 less, it's 1 more. So 7 pi over 6, 7 is 1 more than 6. 5 pi over 4, 5 is 1 more than 4. 4 pi over 3, 4 is 1 more than 3. And 3 pi over 2, 3 is 1 more than 2. Simple stuff. It's like I said, once you learn the patterns, it's a very simple thing to understand and learn. Now we get into the fourth and final part of the unit circle. This one is definitely the most confusing out of all of them, the pattern at least is what I'm talking about. But it's still fairly simple to understand as long as you can memorize it. The numerator is always 1 less than double the denominator. So let me explain that to you. 2 times 2 is 4, and 3 is 1 less than 4. 3 times 2 is 6. 5 is 1 less than 6. 4 times 2 is 8, and 7 is 1 less than 8. 6 times 2 is 12, and 11 is 1 less than 12. So the numerator is always 1 less than double the denominator. It's kind of confusing, but it's simple to understand. Now I'm going to fill in the blanks for all of the actually, I'm just going to do the coordinates. I'm going to fill in the coordinates and show you guys how to memorize that. Very simple, starting with the first part of the unit circle. Now looking at the coordinates, you're probably thinking, well, that's just a bunch of random numbers. How on earth am I supposed to memorize that? And I apologize for my sloppy handwriting. I'll explain it to you. So, closest to the x-axis is always going to be root 3 over 2, 1 over 2. It's going to be the same for here, for that one, same for that one, and the same for that one. So I'm going to fill that in and show you guys. So as I said, it's always going to be root 3 over 2, 1 over 2 in the spot closest to the x-axis. The next pattern is similar to the angles, or not the angles, to the radians, yes. 1 over 2, root 3 over 2 is always going to be closest to the y-axis. So I'm going to fill that in and show you guys. In case you guys haven't noticed, the one closest to the x-axis and the one closest to the y-axis are the same thing. They're just flip-flopped. That's an easy way to remember which one it is. It's kind of confusing trying to remember which one goes where, if it starts with 1/2 or √3/2 for that one. It's confusing memorizing which one goes to which corresponding angle, but once you memorize the unit circle, it becomes easier to understand it. It's easier to learn it. The next pattern is in the middle, just like it's over 4. In the middle will always be √2/2, √2/2. I'm going to fill that in and show you guys. So now you're probably wondering, well, why don't they change? Why are they the same for every single part of the unit circle? And this is where I'm going to explain that they do change. They don't change numbers-wise. They stay the same the entire way around. The only thing that changes is if it's positive or negative or not. And much like a coordinate plane, actually, I'll write the quadrants on the circle. Give me a second. So this follows the same quadrants as a coordinate plane, which is basically what a unit circle is. It's a circle and a coordinate plane kind of combined together to give you answers to trigonometric functions. I'll explain that later after that. So in quadrant 1 of a coordinate plane, the x and the y are both positive, and that's what they are here. Quadrant 2, the x is negative, but the y is positive. So I'm going to fill that in real quickly and show you guys what it looks like. So said the x is negative, but the y is positive. In quadrant 3, x and y are both negative. I'm going to do that real quickly. So, as you can see, I folded in. They're both negative. Follows the rule. I wrote it down in the corners so you can see that. That's an easy way to remember how to do that. And then quadrant 4, x is positive, but y is negative. So I'm going to write that in real quickly. So that's basically drawing the unit circle and memorizing it. If you can memorize those patterns, you'll be able to memorize the unit circle fairly easily. It's not that hard. It looks like a lot, but it's really just a bunch of a bunch of fairly easy to remember patterns, all into one that will give you the answer to solving it. It's a bunch of easy I'm sorry, I'm not good with English. It's a bunch of easy patterns. And once you memorize those patterns, you can memorize the unit circle. It's fairly simple to do. Now, there is quite a few things you can do with the unit circle. One of the main things you use, basically the only thing you use the unit circle for is trigonometry. But trigonometry is such a wide topic, there's so much involved in it, that's why the unit circle is a very important thing to use. It's not something you have to memorize unless, you can use a paper or sometimes a picture of it to you get answers off of it and use it when you're doing homework or something like that, but sometimes teachers will make you memorize them for tests or quizzes or stuff like that. So I would advise people to memorize it. It makes it a little bit easier to be able to have it in your brain and not have to rely on a piece of paper for it. But one of the things that you use the unit circle for it's basically a cheat sheet for trigonometry. And basically, when you do trigonometric functions, you'll get answers in either angle degrees, like the angles, or radians, and sometimes it asks you to convert those. And all this does is it shows you exactly how. It's like a cheat sheet. It just kind of converts everything for you. These are all the most common ones you'll end up using in trigonometry. You'll end up using a lot more, and there's more functions to do it when they're not on the unit circle. They're kind of bizarre. That's not part of this, so I'm not going to teach you guys how to do that. But the unit circle is basically a cheat sheet for all the most common ones that will come up in trigonometric functions as you do them over the course of your classes that involve trigonometry. So it's a very vital thing to learn. It's fairly easy to memorize once you memorize the patterns. And yeah, that's about it about the unit circle. It's a very vital piece to know when you're doing trigonometry, and it's a very important thing to understand. And if you don't understand it, you should probably ask for help from a teacher, or go online and look it up or something like that. But yeah, that's all there really is to it. That's all I have to say about the unit circle. It's fairly easy to memorize and it's important. So yeah, that's the end of the video. I'll just leave leave this here for a few more seconds so you guys can take a picture or screenshot of it if you want to copy it. So, yeah, that's the unit circle.